Alright, question 30 says, points B and C lie on the line AD, as shown below. Something like this. Oh, it's supposed to be a straight line. This is D, this is A, B is about here, and C is about there. And it says, the length A to C is 16 units long, and length B to D is 20 units long. So A to C is 16 units long, and B to D is 20 units long. How many units long, if it can be determined, is B to C? Okay, oh, and this entire line length is 30 units long. So you might be tempted to just subtract 20 from 16 to get this middle piece of length BC, which is just before, but that's not correct. There's more to it. So if we think about it, this whole length is 30 units long. But if we add these two lines together, A to C and B to D, if we add AC plus BD, we'll get something that's 36 units long. So it's 6 units too long to fit on the actual line A to D. So we must know, or we can conclude that they're overlapping parts. This section right in here, this length, right from there to there, from C to B, you can draw it like that, that is 6 units long, because we need A to D, we need the length AD to be equal to 30. So since their combined is 36, we know that their overlapping lengths will be equal to 6. And that's the answer for question 30. We'll go on to question number 31. And it says, question 31. Separate these two questions. What is the x-coordinate of the point in the standard xy coordinate plane at which the two lines y equals 2x plus 6 and y equals 3x plus 4 intersect? So where do these two lines intersect? What is that? It wants to know specifically what is the x-coordinate at which they will intercept. So we know that the x-coordinate which they intercept will be the same for both lines, because both lines will be at that point. These aren't exactly what the lines look like, but this is just the idea behind it. If we have one line like this going that way and one line like this, we know that when they intersect, they'll both be at this same x point and they'll both be at this same y point, because they're at the same spot, they're intersecting. So we can figure, or we can just use substitution here, because their y's will be the same. We can say that 2x plus 6 is equal to 3x plus 4. Because remember, their y's are the same exact values because they're at the exact same spot. So now we can just solve for the x's using simple algebra. We get 2 equals x. I just subtracted the 4 and subtracted the 2x. So we just see 2 is equal to x. And that's the answer. And if we wanted to find the y-coordinate, we could just plug this 2 back into this equation, and that would be 2 times 2 plus 6 is equal to 10. And if we plugged it back into here, we should get 10 too, because they're at the same y value. So 2 times 3 is equal to 6 plus 4, y would be equal to 10. So we know we did it right. And we'll go on to question number 32, which says, I'll clear this space so we have more room to do question 32. And it says, for question 32, for all pairs of real numbers m and v, where m is equal to 3v plus 6, what is v equal to? So for any number we plug into v, we will times that number by 3 and add 6, and we'll get the number m. And it wants to know, how do we create an equation like this for v in terms of m? And to do that, we can just use simple algebraic manipulation. If we subtract, or it's basically asking to isolate v, in other words. So if we subtract 6, we will see that we have m minus 6 equals 3v, and now we can just divide by 3, and we get m minus 6 divided by 3 is equal to v. So that's the answer, but what does this mean? It means that for whatever number we plug into m, we'll get this value v. And if we plugged that same value v into this equation up here, we would get the m that we plugged into this equation. Okay, I'll see you in the next video.